and welcome to this session. Have you ever thought about how computers do addition and subtraction using binary? Today, let's explore the adder subtractor and understand how it works. We'll also look at the construction of circuits using this concept.
Objectives. At the end of this session, you will be able to list the tools, equipment, and materials required for the construction of adder-cum-subtractor and constructor of 4-bit binary adder circuit using adder-cum-subtractor IC74LS83 and verify the result. Before we begin assembling our circuit, let's ensure we have all the necessary tools, equipment, and materials at hand. You will need the following tools and equipment such as digital trainer kit 1 number, digital multimeter with probes 1 number, wire stripper 1 number, and tweezer 1 number. You will also need the following materials and components such as IC74LS83 16-pin 1 number, IC7486 14-pin 1 number, hookup wire as required, and datasheet for ICs. What is adder-cum-subtractor? An adder-cum-subtractor is used in adding and subtracting binary numbers. It is made up of full adders connected in parallel with each other. The Cout of one full adder is connected to the Cin of the other adder, which enhances the process of addition and subtraction. During an addition, the control signal is deliberately kept in the low state. Therefore, the binary number B7 through B0 passes through the controlled inverter through XOR gate with no change. The full adders then produce the correct output sum. For instance, suppose the numbers being added are plus 125 and 189. Then A7 through A0 is 0111101 and B7 through B0 is equal to 10111101. Since control input is equal to 0 during an addition, the carry in to the LSB column is 0. Let's now look at the IC used for this procedure. The 74LS83 is a fast 4-bit full adder IC with a carry-out feature. It contains 4 separate full adder circuits in one package, commonly used for arithmetic operations. If needed, multiple ICs can be connected for more than 4 stages, known as nibble adder. Let's now dive into the procedure of construction and testing of 4-bit binary adder circuit using IC7483 and tabulate the readings. It involves the following steps. They are: Step 1. Inspect the components and set up the breadboard. Step 2. Connect both the IC power pins to plus 5 volt and ground. Step 3. Attach switches for different levels to input. Step 4. Connect all the outputs of ICs to the LED through resistors. Step 5. Test the circuit by toggling switches. And Step 6. Observe and record the readings. Let's now look at each step in detail. A word of caution. Follow all the safety standards discussed in the previous exercises and ensure it before initializing the procedure. Once you're ready, collect all the required components and check them to ensure they are in a good working condition. This includes both 7483 and 7486 ICs, the digital trainer kit, which includes the breadboard, power supply, toggle switches, resistors, and LED. Check the digital trainer kit and all the required sections on the digital trainer kit to perform this task. Also, ensure the conditions of both 7483 and 7486 ICs, breadboard, and control toggle switches, resistors, and LED. Once you've got everything, mount both the ICs firmly on the breadboard. You can use the circuit diagram for reference. Connect the plus 5 volt of the digital trainer kit to the positive terminal of the breadboard. Next, connect the 5th pin of IC7483 to the power supply and connect the 14th pin of IC7486 with a plus 5 volt supply. Then, make sure pin number 12 of IC7483 is connected to the ground. and pin number 7 of IC 7486 is connected with the ground. Connect the ground of the trainer kit to the negative terminal of the breadboard. Moving on to the inputs, connect the toggle switches S1 to data input A3 at pin number 1, S2 to data input A2 at pin number 3, S3 to data input A1 to pin number 8, and S4 to data input A0 at pin number 10 of IC 7483. Also, connect switches S5 to the first pin, switch S6 to the fourth pin, switch S7 to the ninth pin, and switch S8 to the 12th pin of IC 7486. The second, 5th, 10th, and 13th pin of IC 7486 are interconnected, and connected with the mode selector switch S9, which is connected to pin number 2 of IC 7486, and the same should be connected with the 13th pin of IC 74LS283. Now, connect the output obtained from pins 3, 6, 8, and 11 of IC 7486 to pins 16, 4, 7, and 11 of IC 74LS83 respectively as operand B inputs B3, B2, B1, and B0. The final output, that is S4, S3, S2, and S1, and Cout are obtained from 15, 2, 6, 9, and 14th pins of IC 74LS83. Also ensure switches can toggle between 5V for a logic high and 0V for logic low according to the logic levels you will test as shown in the truth table. This will help us to see the result of a 4-bit binary adder circuit clearly. Before you power up, get your assembled circuit checked. With everything checked, switch on the 5-volt DC supply. We can now verify the circuit by taking an example. Before performing addition, make sure the selection mode input is in low state. Now, take two 4-bit numbers, that is 9 and 10. Assign the byte positions for input A. A3 1, A2 0, A1 0, A0 1. Assign the byte positions for input B. B3 1, B2 0, B1 1, B0 0. After performing addition, the result obtained is 19, that is 10011. Verify the result by observing the status of the LED.
This brings us to the end of this session. In this session, we have learned the tools and materials required for the construction of adder cum subtractor in construction of a 4-bit binary adder circuit using adder cum subtractor IC 74LS83 and verify the result. Thank you for watching. We will see you in the next session.